Now, the study of two-dimensional motion is a little bit more complicated than one-dimensional motion, but it is understandable, totally understandable. I'm going to work out 4 types of questions that will clearly illustrate the principles of two-dimensional motion. Now try to follow along at each step. First of all, we're going to consider that an object is dropped. All right, object is just dropped from a height of 19.6 meters from the ground. So the object is being held at rest and it's just dropped vertically from a height of 19.6 meters. And we are trying to find the time taken for this to hit the ground. Of course, this is one-dimensional motion because it's only moving along the y-axis. And in this case, the initial velocity is 0, both along the x-axis and the y-axis, because it's absolutely at rest, right? So its initial velocity is 0. So here is the picture. So that's the object there, 19.6 meters above the ground. And then you have the initial velocity along the x being 0 and also along the y being 0. So that's what that shows. And if this object is dropped, the acceleration is the acceleration due to gravity, which is negative 9.8 meter per second squared. And we are trying to find the time that it takes to hit the ground. We know that delta y is negative 19.6. Negative because it's going down. And so the formula that has these four terms is delta y is v naught t plus 1/2 at squared. So plug it into that formula. Delta y is negative 19.6. I won't even write this term because 0 multiplied by anything is 0, so this term vanishes. And then you have 1/2 times negative 9.8 times t squared. 1/2 times negative 9.8 is negative 4.9. So you get negative 4.9 t squared. Divide both sides by negative 4.9. And that'll cancel out and you get 4 here. And when you take the square root of 4, you get 2 seconds. Why should you take the square root? Because what you have here is t squared. So now we find that the time taken for this object to hit the ground is 2 seconds. That's right. All right, so here, that's one-dimensional motion. Now let's consider that there is a ball held at the same height, but this time I'm not going to drop it down. I'm going to give it a horizontal velocity, a velocity perfectly along the x-axis, but it's dropped from the same height. And so the path it takes is going to be parabolic and it's going to hit the ground, but it's going to take the same time to hit the ground. I'm going to prove that. And the proof is simple, but this is what you have to understand and very important. Although I give this a horizontal velocity, its initial vertical velocity is still 0. It's true that I've given it a velocity, but that's along the horizontal. So you should be able to see the difference between the horizontal and the vertical. So here is the diagram. So this object, I'm going to give it a horizontal velocity. That means along the x-axis of 10 meter per second. But its initial vertical velocity is still 0. Therefore, this is the path that it takes. And when you look at the diagram, you should understand this is another very important point, that the horizontal velocity of this object, which is 10 meter per second, never changes. Never. So that's why you see it started at 10 meter per second. After some time, it's still 10, all the way down just before it hits the ground, its x velocity is constant at what? At 10 meter per second. It never changes. Now what about the y? Look at the delta y. Isn't this exactly the same as this? Yes. So although this object is taking a different path, that doesn't matter because the vertical displacement is still negative 19.6. So that means all the quantities here are the same here. I'm not going to write all of them again because the initial vertical velocity is 0. The acceleration is negative 9.8 meter per second squared. Delta y is still negative 19.6. So the time when we use this equation is still going to be 2 seconds. So this object is going to take 2 seconds to hit the ground. All right, I hope you got that. But the next thing is, it also has a delta x. How do you calculate the delta x? There is only one formula that will work all the time on delta x because the velocity along the x is constant. All you got to do is multiply that constant velocity with the time. You will get delta x. Let me show you. All right, so all of that is constant at 10 meter per second. I've explained that. And then 10 multiplied by 2, 20 meter is going to be delta x. Okay? So here it is. Delta x is the constant velocity along the x-axis multiplied by the time. What is the constant velocity? That's 10. So 10 meter per second multiplied by 2 seconds will give 20 meter. I hope that's clear. So although it takes a different path, takes the same time, but it has a delta x. This object did not have a delta x. See, that object did not have a delta x, but this one did. Okay, so that must be clear. Now we're going to discuss a different situation. In this case, the object is going to be projected at an angle. So instead of throwing it horizontally, it's going to be thrown at an angle. So when we have that, we will have both an initial horizontal velocity and an initial vertical velocity. So let's assume that it's projected at 10 meter per second and at an angle of 30 degrees. So when you have that, you always break it up into the horizontal and the vertical. The horizontal will always be the velocity multiplied by cosine of the angle. That means it'll be 10 cosine 30 in this case. So the horizontal is always the initial velocity multiplied by the cosine of the angle. So when you do that, it happens to be 8.7 meter per second. And then the vertical, V naught y, I'm going to write it here because I don't have space there. V naught y is always V naught sine 30. So you see the difference. One is cosine, the other is sine. The horizontal is cosine, the vertical is sine. And that is 5 meter per second. And then this is the path that it's going to take as it drops to the ground. It's going to go a little up and then come back down, correct? And we have to find the time. Just like we did before, we will use the same formula. We will take the y quantities. So that means we are assuming that it's at the same height of 19.6 meter, okay? So delta y is negative 19.6 meter. The initial vertical velocity is 5 meter per second. Acceleration is negative 9.8 meter per second squared. and we are looking for time. So when you find time, you use the same formula as before, which is delta y is v naught t plus 1/2 at squared. So when you plug it into that, delta y is negative 19.6. Then you have 5t minus 4.9t squared. Why 5t? Because v naught y is 5. So that's 5t. And then how do you get the 4.9? Because it's 1/2 times negative 9.8. So 9.8 by 2 gives 4.9. So you're going to get a quadratic equation here. Carefully, you have to arrange all of them onto one side. So I'm going to take both of these to the other side, which means the signs on both will change. So it'll become plus 4.9t squared minus 5t minus 19.6 is equal to 0. Now the sign of negative 19.6 didn't change because it was already on the left side. And once you get the quadratic equation, you must know that 4.9 is A, 5 is B, and 19.6 is C. And from your formula sheet, here is the quadratic formula. Minus b plus or minus square root b squared minus 4ac by 2a will give you the value of time. So carefully plug in. Minus of minus 5 is 5. Plus or minus b squared, b is 5. 5 squared is 25. And then you go 25 minus 4 times 4.9 times minus 19.6 because it's 4ac divided by 2 times 4.9. So work this out carefully because you got to first find out what's under the square root. And you would get 5 plus or minus 409.16. That's under the square root. When you take the square root of that, you get and solve it, you are going to get 2.57 seconds. You need not go for the negative value because time cannot be negative. So you take the square root of this number, solve it, you get 2.57 seconds. All right, once you get the time, remember to find the delta x, we always use the same formula, which is Vox multiplied by time. Now, Vox is 8.7, wasn't it? 8.7 multiplied by the time that we just got, 2.57, that'll give 22.36 meter. That is how far it will fall. I hope you got that. So here is a third question. In this question, a long jumper is taking off from the ground and landing back on the ground. So that's a different situation. And so this person is launching himself or herself at an angle and with a velocity. So here is the question. Read along and try to understand. You will get this. A long jumper leaves the ground at an angle of 20 degrees to the horizontal. That means to the ground. And at a speed of 11.0 meter per second. A, how long does it take for her to reach the maximum height? How long does it take for her to reach the maximum height? And B, what is the maximum height? This is third part. C, how far does she jump? All right. So here there are three parts. Remember, she takes off from here. She is going to reach a maximum height. So you have to first find how long she takes to reach the maximum height. Okay? And then remember that's the ground. And then you got to find what the maximum height is from the ground. What the maximum height is from the ground. And then you got to find how far she jumps. So from the starting point to the finishing point. How far did she jump? So those are the three. And so first we have to draw this diagram. She makes an angle of 20 degrees. 11.0 meter per second is the speed. What do you do first? Break it into its components. What's the x component? Always cosine. So 11 cosine 20. 11 cosine 20. What's the vertical? It's going to be 11 sine 20. 11 sine 20. And 11 sine 20 from the calculator is 3.76 meter per second. And 11 cosine 20 is 10.34 meter per second. Now we got the components and we do the same exact thing like we did before. First, we focus on the y component. What's the initial vertical velocity? It's 3.76. So we do not go back to 11 because we already used the 11 to break it into its vertical and horizontal. So now we go to the initial vertical velocity, or the velocity along the y, is 3.76. Excuse me. The acceleration is negative 9.8. We have to find the time to take that she takes to reach the maximum height. Now what's important about the maximum height is when she reaches the maximum height, the vertical velocity becomes 0. The vertical velocity becomes 0. So that's why we have Vfy is equal to 0. And then when you look at these quantities, you try to figure out these quantities, you try to figure out the equation that contains all four of them. This is not the same as before. Now it's Vf is equal to V naught plus AT. Excuse me. So V naught is 3.76, A is negative 9.8, multiplied by T, and you rearrange and calculate, you get time as 0.384 seconds. Hope you take some time to understand that math. So that's the time that she takes. It's a small time, obviously, because it's really to go from the ground to the maximum height. Next part, what is the maximum height? Again, we use the y quantities, right? So let's do it. We know the initial y velocity is 3.76. We know the acceleration, negative 9.8. And we now did find the time to reach that maximum height. And we can find y. So y is what we're trying to find, okay? So this time the formula is different. And this is the formula. You always look at the quantities to find which formula you have to use. So when you plug it in here, you get 3.76 multiplied by the time plus 1/2 times negative 9.8 times the square of the time, because there is t squared there. And now remember there are two terms here. This is one term, this is the second term. Calculate that carefully. You get 0.722 meters. That's the maximum height. All right, now the third part. How far does she jump? How far does she jump? So that means now you're looking for x, correct? Since you're looking for x, remember there's only one formula that works on the x. What's that? You take the velocity along the x, which is 10.34, multiplied by the time it takes. But don't make a mistake, we got the time to reach the maximum height, didn't we? It'll take that much more time to come back to the ground, so we got to take double the time that it takes her to reach the maximum height. Okay, because this is just halfway. You double that time, that'll be the total time it takes for her to go from ground to ground. Multiply that time with 10.34, that'll be the answer. Here it is. That's the track. A to B is the X we're looking for. We got the time from A to C. That's why we have to double it. So 2 times 0.384 gives 0.768 seconds. And then delta X is always V naught X multiplied by time. V naught X is 10.34 multiplied with 0.768, and you have your answer. This happens to be 7.94 meter. All right, here's the last one, last problem in this set. And here we're going to talk about a boat that's cutting across a river. It's trying to go from one side of the river to the opposite side. Okay, so there are 2 velocities now. One is the speed of the boat, and the other is the speed of the water flowing in the river. So here's a question. It's going to come fast. A boat is heading north, so that's north, across a river with a velocity of 10 kilometers per hour and related to the water. And the river has a uniform velocity of 5 kilometers per hour due east. So one is north, the other is east. Determine the magnitude and direction of the boat's velocity with respect to an observer on the riverbank. So this is called relative velocity. So when I make the diagram, it should become much clearer. So that's how the boat and the river are flowing. So that's the direction that the boat is trying to head to. And this is the direction of the flow of the water in the river. Well, is the boat going to reach there? Definitely not. Because the boat is going to be carried downstream as it goes up. Correct? So it's trying to go straight across, but it can't because the water is flowing to the east. So the boat is going to take that path. And that will be the magnitude. In fact, that will give you the magnitude and direction of the boat's velocity. So let's complete the diagram. So that's the path that the boat takes. Now, what's given? The first term is called VBR. That means velocity of the boat with respect to the river. So that's how you read it. Velocity of the boat with respect to the river. That's given. And then you have the velocity of the river with respect to the earth. The earth is the bank. And then what are we trying to find? We're trying to find the velocity of the boat with respect to the earth. And this is very simple because you can see a right angle triangle there. Right there you see a right angle triangle, don't you? And use the Pythagorean theorem to find that. Because this is a hypotenuse. The square of the hypotenuse is equal to the sum of the squares of the sides. I hope you remember that. So all you got to do is square this, add them, take the square root. And I'm keeping it in kilometer per hour. It doesn't matter here. So 10 squared plus 5 squared, take the square root, you get 11.2 kilometer per hour. And then when we try to find the angle, this is the angle we're looking for. And from this right angle triangle, tan theta is opposite side by adjacent side. That's the definition of tan. So you need to remember your SOHCAHTOA. TOA, T-O-A. That means tan theta is opposite by adjacent. So when you do that, the opposite is VRE, which is 5, and the adjacent is VBR, which is 10. So you're going to get 5 divided by 10, that's tan theta, which is 0.5, and then you take the inverse of that, tan inverse of 0.5. Use your calculator, hit the shift key, plug in, hit tan, and then plug in 0.5, you will get it as 26.6 degrees. How long will it take for the boat to cross this river? Well, that's real simple because now you know that the width of the river is given as 5 kilometers, and we know the velocity along that direction, which is 10 kilometers per hour. All we got to do is delta y is VBRT. So 5 kilometers, which is the width of the river, is equal to the velocity along that direction multiplied by time. And you get time as 5 by 10. It's going to be actually 0.5 hours. It's going to be 0.5 hours, means half an hour. This is how we do problems in two-dimensional motion. Is it going to come easy? No, never. Can you get it? Yes, by practice. First of all, you got to rerun this video and look at these 4 questions and try to understand what I'm doing. If you get these 4 questions, pretty much you will get every question on the exam that's asked from this chapter. So good luck, thank you, and see you on the next video.